Hello, in this demonstration I will show how to run a regression in Python. I'll do it without and then with the pipeline. The idea is this is a review. Assume that you already have done this, but this is a review, a reminder, so that in the next video I can show you how to do the same steps in PySpark. So here is a scatter plot of some data. There is average area income on the x-axis and the price of the house on the y. And with the one variable regression, we're going to take the average area income and then try to predict the associated price. So this is what it looks like when we put a line through it. Here's some points through a line through some points, and our y is what we're going to predict. The x is what we're given, and this line, it can be defined by the slope, which is also here the coefficient for x, and the intercepts where the line meets the axis at x equals 0, this spot here. So we're going to try to find this line using ordinary least squares over the data we're given. So here's the data again, and we're going to put a line through it, and that's what the linear regression is going to do. I'm going to do this in Python. So how does it work in Python? Well, typically in Python, we're going to have two variables. It's a series of values, the x and the y. This will be slightly different when we do it in PySpark, where it's going to be in one data frame. But here in Python, we have x is defined by in this case, one series, the average area income, and later on it can be a set of series multivariable regression. The y is defined by one series, in this case, price. So we'll take the sklearn kit and we'll use the linear regression class and make an instance of it. And then we'll fit that class to our two variables here, our x's and y's. And once we have that model, then we can predict things with the model. We can say, given some value, tell me what the value of x, tell me what the y is. So in this case, give me some average area income as input, say 18,000, then the average house price, according to this model, is about 160,000. So that's the model we're going to produce by fitting it against the data. So we're going to use the sklearn pipeline eventually, after doing it without the pipeline. We'll split up our data into training and test data. And with the pipeline, we're going to do a couple steps. And just for the sake of demonstration, I have a normalization step doing the standard scalar, and then followed by the linear regression I introduced before. And just like you fit the linear regression against the data, we fit the pipeline against the data. Same process essentially, and as a result we get a fitted pipeline or fitted model. And then once we have that, then we can print out various things about the model, like the coefficient, intercept, and so forth. So that's what I'll show you, is how to do this with Python. So let's do it in Databricks. Here I am in Databricks. I've just created a PySpark or a PySpark cluster. And even though it's PySpark cluster, I can go ahead and run regular Python, and that's what I'm doing here. So when I run the next video that has the PySpark regression, it'll look identical, but it's going to be using the PySpark library. So I first start off with some data, some housing data. I'll import some libraries. These are all going to be regular Python libraries. I'm going to use pandas to read the data file, comma separate values, into a USA housing data. I can review the data and describe it. And then I'm going to use the sklearn kit, in this case, to do a linear model. I'm going to take my housing data. It has a number of columns, as you can see here, but the first time around, I'm just going to do a simple one variable regression where my 1x is going to be the column for average area income. And then using that, I'll predict prices. Later on, I'll take more of these columns and predict price. All right, so let's just do this one variable regression just to make it simple. Here's a scatter plot of the data. I use a Seaborn to do a scatter plot. Here's the pandas data frame. I give it the X and Y's and a title and plots it. Just a reminder of what this is going to look like. We're trying to find this line that best fits to the data. All right, so let's do it. So we grab our linear regression model from the sklearn library, the API. This is an instance of that class. LM is an instance of the class. And once I have that instance, I can fit it. So I fit it against my X's. In this case, the X has just one column, and it's the average area income. The Y is a column, or a pandas series of the prices. All right, so now I've got my fitted model. That's what LM is. Now I can go ahead and get some information about it. Like I can get that coefficient. That's going to be the M in my equation. And I can get the intercept, which is the B in that equation. And I can, in fact, use plot here to plot the actual equation here. I have the data plotted first. That's my scatter plot. And then I plot the equation in red. And that's the actual equation that we have generated from the linear regression model. So that shows you what it looks like through the data. I can also use Seaborn's reg plot, which is a little bit more convenient, which I'll continue to use afterwards. Same idea, it should be the same line. All right, so that's my one variable regression, and once I have that, I can predict things with it. So here's my model, my linear model. It has a predict method on it. I can give it as input one of the values in my X's, because I just have X's predicting Y's here, one X column, which is the average area income. So if I give it the average area income of 18,000, then that's going to predict that about 159,000 for 160,000 for the price of the house. I can go ahead and print out all of those predictions using LM predict and give it the X's, and I'm going to get all my results. So later on, I can use that to plot actuals versus predicted. I can also get some metrics about how good a fit it is. In sklearn, there's metrics, and there's a R squared, R2 score. And once I take my predicted values for my X's, I get my predicted Y's. So I have my actual Y's, I have my predicted Y's, and I can pass that to R score and R2 score and get the R squared value, which is 0.409, which is not very good. There's a little summary here about what R squared is. This is essentially the distance between the fitted values here and the actual values, and we're going to square them and then subtract it from 1. And so if there's no distance between our fitted values and the actuals, then R squared is going to be 1. And if there's a giant distance, it's going to be closer to 0. So we want R squared to be high, close to 1, indicating we've got a good fitting model. Okay, so once I have my model, then just to point out, I can print out information about it, like the coefficient, the intercept, the equation here, and the fit metric. That's all my one variable regression. Now I'm going to use multiple variables to predict the prices. So next up, let's do that. And you can see there's a number of columns, and I'll use those columns. In fact, I'm going to start off with my housing columns. I'll remove the price column, which I don't want to work with because that's what I'm predicting, and the address column, which is text, which is not going to be helpful because I'm not doing any text mining here. So I just take the other columns, and I'm going to put them all in X here. So I have my pandas data frame. I'm grabbing out, selecting all the columns that are not price and address. So now X is multiple columns. It's this data frame here, pandas data frame. And then Y is price. Okay, so now I can go ahead and take my X's and Y's and split them. So I got my training and my test data for both X's and Y's. which is common to do, first train and then test on the other portion of the data. And I'm going to go ahead and take my linear regression just as I did before and fit it to my training x's and my training actual values, the y's. Okay, then I get a new model. This model now has multiple columns, not just one column, and the R squared should be a little bit better. You can see here my equation is I've got an intercept and then some coefficients for each of the columns I've selected. The R squared in this case did it again, given the predicted values. I also did it based on the test data, not the training data, and it performed okay. It's a 0.917, so that's quite good actually. So this is a standard way of running Python linear regression. You can also at the end plot your actual values versus your predicted. Here's my actual and here's my predicted. And ideally it's a pretty good, fit and it looks pretty good, and that reflects what you see in the R squared. It's a pretty good fit. Okay, so that's sort of the standard way of doing linear regression in Python. Now let's go on to a pipeline. Not everyone does this, but you'll want to do this with PySpark, and so that's why I'm demonstrating it here. So sklearn has a pipeline. In fact, PySpark's pipeline is based on the API here from sklearn. So they use the same general idea of the pipeline. So once again, we have our data split up. And now, instead of just doing a direct application of the linear regression model to the data, we're going to do a pipeline. And this first pipeline only has one step, and so it's not going to be very interesting, but just to go step by step through this process to show the minimal change, I just have a pipeline now that has only one step, and it's just the regression, just as we demonstrated above. So it's a linear regression model. It's called Regressor, and we take this, it's simply a list of names and classes, and we're going to put them in this input to the pipeline, and then as a result, I get a pipeline. So once I have that pipeline, I can go ahead and fit that pipeline to the data just as I did before. So if we looked at before, when we did the regression, just made an instance of the linear regression class, and then I fitted that class to the data. And the same thing is going on here. It's exactly the same thing. We have an instance of the linear regression class. It's declared as one of the steps. I pass that off to the pipeline, and the pipeline then is fitted against the data. And that in turn processes each of the steps. And in this case, you only have one step, and so that linear regression object is fitted against my data. You can see the result of this fitted model, which is a fitted pipeline. And here's the pipeline object, and you can look inside and see that it has the regression that we specified above. We can then pull out of this multiple steps. In this case, I just got one step, but we can pull out the name and the actual object, the linear regression object. I'm just pulling it out of this list using some Python notation. Okay, so once I have that, I can use the same steps I did before to take that linear model and print out its coefficient, intercept, and all the rest. Including below, I can take my linear regression model and use the prediction method and apply it to the test data, and I get my prediction. So everything's identical. Before, I think it was R squared of 0.917, and we have that 0.917 here. As before, I can again apply the same old plotting in order to plot the actuals versus the predicted. Okay, so that's the pipeline with just one step. It's sort of boring. Let's now go on to how you more realistically use the pipeline. And typically to actually have more than two steps, but I'm just trying to keep it simple here. So I've got two steps in my pipeline. It's just defined as a list where each tuple in the list is a name followed by a class instance. So in the second element I have is my regressor name and the instance of the linear regression class. I added this time just, for the sake of demonstration, a standard scalar, which is probably not necessary, but I've just added it here, and I call it normalized just to give it a name. And you can give it any name you want, of course. Now I've taken those steps and defined my pipeline, an instance of a pipeline that relies on these steps. Now once I have that pipeline object, I can go ahead and fit it to my data. So this, you can see now, the fitted model is a scalar in the regression as defined above, but it's been fitted to the data. And once again, I can pull out my name and my model, but again, this time it's going to be the second element of the list, which is labeled 1 here because our list, starts with 0 in Python. So I can print out that the name is regressor, and I can see that my model here that I pulled out of these steps is linear regression model. And as above, I can go ahead and print out information about it, the coefficient, intercept, and so forth. And as above, I can use R squared to take that fitted model and do prediction, and then get an R squared, once again 917. So everything's the same. It's interesting here that the scalar didn't change. I think it's 91768, and if I look above, it should be the same. Here it is, 91768. So turns out in this case, and typically the scalar, that standard scalar is not going to make a difference. But anyway, for demo purposes, I just wanted to include a couple steps in my pipeline and print out the information about the R squared, and then of course I can do the usual actual versus predicted. And that's it. So that's the simple run through of running a Python regression. I'm just using Databricks, and some people might be new to see how to do the pipeline. That'll be important because the next video will go over how to use the pipeline in PySpark to do linear regression. So I hope that works for you.